In this question, it is given that the urns A, B, and C contain 4 red and 6 black balls. Urn B contain 5 red and 5 black balls. Urn C contains lambda red and 4 black balls respectively. If one of the urns is selected at random and a ball is drawn, if the ball drawn is red, then the probability that it is drawn from the urn C is 0.4. Then the square of the length of the side of the largest equilateral triangle inscribed in the parabola y square equal to lambda x with one vertex at the vertex of the parabola is dash. You have to fill in the blank. According to question, suppose these are the 3 urns A, B and C. The first urn contains 4 red and 6 black balls. Second one has 5 red and 5 black balls. Third one has lambda red and 4 black balls. And then it is given that we select any one of the urn and select a ball from it. And it is given that the ball selected is red and the probability that it came from the urn C is 0.4. Using this information, I will find the value of lambda, and after finding lambda, I will use that value of lambda in next part of the question. It's clear that this is the question of Bayes theorem. It's absolutely not a difficult thing to see. Suppose X denotes the event that we have selected the urn A, Y denotes the event that we have selected the urn B, and Z denotes the event that we have selected the urn C. Suppose alpha denotes the event that the selected ball is red, and because it is given that if the ball drawn is red and the probability that it is drawn from the urn C is 0.4, means probability of Z when alpha has already happened is 0.4. Clearly it is a question of Bayes theorem, and according to the formula of Bayes theorem, it is clear that probability of Z when alpha has already happened is equal to probability of alpha when Z has already happened into probability of Z upon this. Means this symbol means the probability that the selected ball will be red when we know that we had selected the urn C, and upon P alpha will be there, and we know that using total probability theorem, this is equal to probability of alpha when Z has already happened into probability of Z upon probability of alpha when X has already happened into probability of X plus probability of alpha when Y has already happened into probability of Y plus probability of alpha when Z has already happened into probability of Z. And now I'm going to put the values. Probability of alpha when Z has already happened means that we had selected the urn C, and we have to find the probability that the selected ball is red. Probability of this will clearly becomes lambda upon lambda plus 4. This is equal to lambda upon lambda plus 4 into probability of Z, that is the selected urn is C, and probability of selecting the urn C is clearly 1/3. And using the similar notation, the value of this probability of alpha when X has already happened means what is the probability that selected ball is red when we know that we have selected the urn A. Probability of selecting the red ball from this urn will be clearly 4/10. 4/10 into probability of X. It is clearly 1 by 3 plus. Clearly the value of this will be 5 by 10 into 1 by 3, because the urn B had 5 red and 5 black balls. And the third part is same as above, that is lambda upon lambda plus 4 into 1 by 3, and the value of this is given to us as 0.4. This implies that lambda upon divided by 2 by 5 plus 1 by 2 plus lambda upon lambda plus 4 is equal to 2 by 5. This implies that 5 lambda upon lambda plus 4 is equal to 4 by 5 plus 1 plus 2 lambda upon lambda plus 4. That is, I get 3 lambda upon lambda plus 4 is equal to 9 by 5. That is, I get 5 lambda is equal to 3 lambda plus 12. That is, 2 lambda is equal to 12. That is lambda equal to 6. And now once we have got the value of lambda as 6, now according to the question, then the square of the length of the side of largest equilateral triangle inscribed in the parabola y square equal to lambda x, that is y square equal to 6x. And now according to question, in the parabola y square equal to 6x, we have drawn an equilateral triangle. With one vertex at the vertex of parabola, and we have to find the largest equilateral triangle inscribed in the parabola. Actually, this word largest is given just to confuse the students, because there is only one equilateral triangle possible in this parabola, because this whole angle 60 means this angle is 30, and if this angle is 30, that is, this line is making an angle of 30 degree with axis of parabola. Obviously, for this point of intersection and for this point of intersection, this will be the equilateral triangle formed. No other equilateral triangle is possible to be made. Hence, if he says the word largest equilateral triangle, that is just to confuse the students, because only one equilateral triangle is possible. This is the parabola and this is the equilateral triangle formed in the parabola, and we have to find the square of the length of the side of the largest equilateral triangle. And suppose this length is L, and because this angle is 60 means this angle is 30, and because this length is L, then this point will become L cos 30 comma L sin 30. That is, this point will become root 3 by 2 L comma 1 by 2 L. This clearly lies on this parabola L by 2. As this lies on the parabola, hence I can say L by 2 whole square equal to 6 into root 3 by 2 L. That is, L will be equal to 12 root 3, and therefore L square will be equal to 144 into 3 equal to 432. Hence answer to this question is 432.